Hi, in this video we're going to look at problem 5 from the problem sheet. The first circuit that is there in problem 5 is shown on the screen here. Now, one way to do this would be to assume the diodes in forward and reverse bias and do the calculations from there, okay? And that's what we're going to do. We will be using the constant voltage drop model, and I'll leave you to do the same circuit using the ideal diode model and see how you get a different output. Okay, so let's assume that the diode is in forward bias. So let's say assume that diode is in forward bias. Okay, in this case, how would the circuit look? The resistance remains the same. This is the output. Here we have this, and instead of the diode you can replace it with a 0.7 volt uh, circuit is voltage, isn't it? So this is Vi and this is Vo. Now in this case, what is Vo going to be? And you can easily see that Vo is equal to 0.7. Now the question is, okay, when is the diode in forward bias? When are you going to get forward bias? Well, we are going to get forward bias when the current through the resistance is flowing in this direction, right? So when IR, we have forward bias when IR is greater than 0, right? Because if IR is greater than 0, that means the current is flowing in the positive direction through the diode, right? If this was reverse biased, IR will be equal to 0. So that's our condition. And so from this condition, now what is IR? IR is going to be Vi minus Vo, or maybe much more, to make it more simpler, we'll just write 0.7 divided by R, and this has to be greater than 0, right? And this means that Vi should be greater than 0.7. So what we get is, we discover that the condition for forward bias is Vi greater than 0, and when you have forward bias you have Vo equal to 0.7. Now you can do the same thing for, you can assume that the diode is in reverse bias. So let's do that. Assume diode in reverse bias. Now we know when it will be in reverse bias, right? If this is the condition for forward bias, the other part of the circuit, when Vo is less than 0.7, we get diode in reverse bias. And in that case, what we have is, you have a circuit like this. This is Vi, this is Vo, and what happens to the diode? The diode is just open circuited. And in this case, what is Vo? Well, Vo is just equal to Vi, isn't it? Okay, so now we have everything that we need to draw a characteristic of this circuit. So let's draw it like this. So let's say this is Vi and this is Vo. So what happens when the voltage Vi is greater than 0.7? Right? We know that Vo is going to be 0.7. So for greater than 0.7, we get Vo equal to 0.7. But this is also 0.7. And for less than 0.7, we have Vo equal to Vi. So we have a characteristic like this. Right? So that is our characteristic. Is that okay? Okay, so let's go on to the next problem. Now, in this problem, the circuit is drawn slightly differently. So we've been told that you have a resistance like this, and the diode, instead of being connected uh, like previously, is inverted, right? So this is Vi, this is Vo, and this is R. So again, what we can do is we can assume forward bias. Okay, I'm going to go through this a little bit quickly because we've already done this. So if you assume forward bias, you get this and you get a voltage like this. Remember, the negative side is at the top because the diode is inverted here, right? So 0.7 volts, and then so this is VO and this is VI. So in this case, what is VO? VO is equal to minus 0.7 volts. And you may ask, what is the condition for forward bias? Now, in this case, we want the current, this is a forward bias diode, so the current should flow in this direction, right? And therefore through the resistance in this direction. And let's call that IR. And say, okay, the condition for forward bias is that IR is greater than 0. And how would you write the equation for IR? It would be minus 0.7 minus VI is greater than 0, or divided by R is greater than 0, right? And from here we get the condition that, what should we get? VI is less than minus 0.7. So it's forward biased there. And what happens in reverse bias? Well, in reverse bias, it's very similar to the previous case. I'm not going to draw the circuit. In reverse bias, you should get VO equal to VI. Okay, and so we can plot the characteristic again. So we get VI, we get VO. For VI less than 0.7, so if this is, let's say, minus 0.7, for less than 0.7, you have VO equal to minus 0.7, right? So let's say this is minus 0.7. So you're basically going to get something like this. And for greater, we have reverse bias, and so you have a graph like this. Okay. Okay, let's take a look at the last problem here. In the last problem, we have, again, this is similar to the problems. So you have a diode here, like usual, but what you'd get is you have a voltage source that is put in series with the diode. So that's your VI, that's your VO, this is 5 volts, and this is R. Okay, let's see how this works then. Again, let's assume forward bias. So in forward bias, how would the circuit look? So the circuit would look like this, right? So that's your resistance. Your diode can be replaced by a voltage source of 0.7 volts. And then you have your 5 volt source. And there you go. Okay. And so what's VO going to be? VO is going to be 5.7 volts, right? It's just the addition of this voltage and this voltage. And what is your condition for forward bias? You can say that IR is greater than 0, and you can define IR in this direction. Let's say that's IR. That should be greater than 0, and you can do the calculations and you'll see that this should be VI is greater than 5.7 volts. And in reverse bias, what you'll have is similar, like before. You'll have, it's not going to change, it's simply going to be VO is equal to VI, right? Because no current flows through this, so this is open circuited, which means VI will be equal to VO. Okay, and so if you draw your characteristic, you should get something like this. So you have VI, you have VO, and you get something like when VI is greater than 5.7 volts, you get, so this is basically 5.7 and this is 5.7, and below that you have VO equal to VI. Okay, hopefully that makes sense.